Good morning. I'm Jeff Pillen. I'm the Director of Energy Assurance for NASEO, and I'll be moderating today's session. I'd like to just note, it's interesting, I think Alice was mentioning to me earlier that we've been doing these for the last 21 years or so, and I think back to our ability to anticipate events 20 years ago and compare that to today. And as I was making plans to come down here, I was watching the track of the hurricane and was delighted to see it started shifting out to the ocean, because I was debating whether or not I was going to change my airplane ticket to come down here. So, but we can do this with such better precision than we used to be able to do it, and we can anticipate things so much better. And certainly conferences like these really help educate and inform us as to the events that are ahead, and I think they're really important to aid in our overall preparedness. So to begin today, our first speaker is Michael Halpert. He's director of the Climate Prediction Center, and he's been working on this in this area since 1981. He led the Climate Prediction Center's real-time climate monitoring efforts through much of the 1990s and their forecast operations between 2002 and 2007. We do have more complete bios in your packet, so I'd refer you to them for further details. And with that, Michael.
Thanks, Jeff. Thanks for the promotion. I'm only back to being deputy, actually. I was acting director for a number of years, but we finally hired somebody, so I get to have part of my life back. David, you started out by talking about some years were on the edge of our seat, and I thought for sure you were talking about El Nino. I guess in the energy biz it's a little bit different. So this is, I don't know, the 11th, 12th, I'm not sure, I've lost track of how many times, but this is one I've been looking forward to since I have something to say this year. Some years it's like, well, geez, I don't know, I got to throw up a map, we got to make a forecast. This year, still certainly no guarantees, but certainly increased confidence, and we'll get to that as we go through here. I'm using my same 12-year-old outline for this. I think I've updated everything in the slide. So just some quick background on the way we issue our forecasts. They're seasonal, so they're averages of 3 months. It's not going to tell you what's going to happen on Christmas Day or Valentine's Day or anything like that. It's averages over those periods for average temperature, which is probably what most folks in here are concerned about more, but also we do one for accumulated precipitation. They're categorical, so it's like, do we think we'll be above normal, near normal, or below normal? I've come to understand that's apparently a very difficult concept for people to understand. We just rolled out a couple weeks ago a week 3 and week 4 outlook, which is a particularly challenging forecast to make, and that one we went just to a 2-class system, so it's either going to be above or below in those. We'll see if folks have a better understanding of that. Areas where there's no basis to guess, basically, and while some folks would be happy guessing, we don't think that's really justifiable or scientific. Those areas, if it's a 3-class system, well, then there's a 1/3 chance of anything happening. And then when we show the map, which we'll show an example of a map, the colored areas, again, these are the areas favored, most likely. I'm not sure how else to say that. I'll talk a little bit when we go forward about last winter, which we actually thought was a good forecast. But then we got a grade of an F in our local newspaper here for one area that I'll discuss in a minute. Anyhow, if you just look at the figure on the left, the temperature, up in Washington, and this is not this winter, so don't pay too close attention to it. This is just an illustration as to what the forecast means. So, in northern Washington, like it says, there was a 45% chance it would be below average, but there was still some chance, and I honestly don't know how this forecast turned out, less chance, but still some chance that it would have been above average. So, I kind of joke with folks that our forecasts are never really wrong. They're never really right either. I mean, there's always some chance of everything happening. If they tell you there's a 60% chance of rain today and you carried your umbrella and it didn't rain, well, 4 in 10 times it shouldn't have rained. I mean, if every time they tell you there's a 60% chance of rain and it rained, then the probability isn't right. It should have been 100%. Okay, so it's a concept that is maybe not intuitive, but that's really what probabilities mean. So we do these forecasts once a month. We're actually here a week before we update these outlooks. NOAA will have our own press teleconference next Thursday on the 15th. I don't think we're going to make big changes when we get an El Nino like this and we get pretty good agreement on everything. I don't think things are going to change. So what I'll show you today will be similar to what we'll probably be talking about next week. And then we'll update it for one last time on November 19th. So I always start, in some years, this is a hard part of the talk when things didn't go well last year, but we'll start and look back at last winter. So when I was here last October, we were talking about El Nino having been neutral, but having kind of flirted with being what we would term a weak event, and we actually favored that to happen. We thought we would see a weak El Nino last year. Other factors that we'll talk about, something, and for folks who have been here, I won't spend a lot of time talking about it today, but the Arctic Oscillation is a what we call a teleconnection pattern. It's a pattern that influences the polar region and the mid-latitudes, so the mid-latitudes where we live. Some years that plays a large role in the outlook. When I get to that, we'll talk more about it. But it's also something that's not predictable on seasonal timescales. So that's one of the things that always adds uncertainty into the forecast. We also like to leverage whatever trends are. Interestingly enough, and we'll get to that as well, the trends for winters have been fairly small. So we were consistent with what we was hoping for with a weak El Nino. There's the temperature forecast on the left. There's what happened over the December, January, and February period on the right in terms of what we call anomalies, departures from normal. So the Heidecke skill score, that's if you just look at the map, which is the way most folks do, and see anywhere where there's color, it should be above average for red and below average for blue. So that scored about a 50, which is actually a good score. I mean, if you were just guessing in 3 classes, you'd score a 0. If you got everything right, you'd score 100. So 50 is we can live with 50. Now, for the folks that live up in Boston, and actually, if you look at the forecast up in New England, Boston is actually in the white area. Okay, it was just. But even still, if you remember from the earlier slide, so there's a slight tilt towards above average temperatures. It obviously didn't happen. That's where we got our F. I looked at that and I thought I could have done a lot worse, so is that really worthy of an F? Maybe a D+, I don't know. Anyhow, so that was last winter. Some of the things we were looking at, I guess when I was here, there was what the tropical Pacific looked like, where we look for El Nino. It was kind of a little bit on the warm side. The figure on the right shows some of the models. I've got a circle around winter. And that first line is the kind of the threshold for El Nino, that red line at 0.5. So there were probably more models above that line than below it. But there were admittedly some that were below it, and we did lean towards El Nino. There's what actually happened. It was interesting that the ocean, the Pacific, was warm, but it was actually kind of further to the left, further to the west than we would see with El Nino. And when you get a pattern like that, you don't get your typical El Nino pattern. So it's not too surprising that we didn't see that. The bottom figure there just kind of shows that during the season, particular November and December, it actually did warm up a little bit in that box. But then as we got further into the winter, it kind of hovered around the threshold. We never saw any interaction with the atmosphere, and that's really what makes El Nino. It's why we care about El Nino. If all that happened was the ocean got warm, it wouldn't have any impacts over places other than if you happen to be somewhere through the Pacific Ocean. But when the ocean warms, then we'll see a much different pattern when we look at what's going on this year. Then we see changes in tropical rainfall and winds and sea level pressure and all kinds of things that will eventually, we expect, impact the weather this winter. So I did just want to show one last slide on last winter, actually, because it's fairly striking how similar especially the end of last winter ended up to the winter before it. And it's not typically something that we would expect, certainly. But if you look here, and this is just kind of, it's probably too technical, but it kind of gives you some idea of where the jet stream might be. And so if you look along the west coast, you'll see the reds and kind of so that's implying that the jet stream is going up north over California. Obviously, 4 years of drought there, so it's not maybe surprising that we've seen a similar pattern a couple of winters in a row that I'm showing here. And then the blues over the Midwest, eastern part of the country again, so allowing really the polar air, Arctic air to come down into the central and last year more into the eastern part of the nation. So forcing that we shouldn't expect to see this pattern again this year. The Pacific, where a lot of the forcing that comes to drive these patterns is much different right now, and certainly will be during the winter. Could we see that again? Well, I guess, yeah, I said, when you deal with climate, anything always seems to be possible. If it happens again, we're really going to have to try to figure out why this keeps happening, but this is really a very low probability event. So this winter, we'll start with El Nino, or for those that don't know Spanish, the Nino. The blue box is kind of the area that we call Nino 3.4. It's just centered in the east central tropical Pacific. That's a very impressive looking map for at least those of us in the business, maybe for you folks as well. All those reds means it's way warmer than it normally is. If you remember what we were looking at last winter or last October when I was here, there was some of that first or second shades of yellow in that area. Here, some of those departures are 2, 3, there's even a 3.5 in there. So this is somewhat reminiscent of the last big event we had, which was actually before I was doing these conferences. I think you guys might have been doing them back in 97, 98. So as it says on the slide, 95% chance that this will last at least through the winter. We update those forecasts on a monthly basis as well. That'll come out on Thursday, but clearly, very, very warm pattern. And when you see a pattern like this, you know it's, like I said, this is, at least in the climate business, this is as close to the slam dunk as you get. So I mentioned 97 because that's been in the news quite a bit, because folks remember, I think, at some level, the impacts or what happened over North America during 97. Actually, all kinds of, all different parts of the planet during 97. Here we're looking, again, that blue box that I had highlighted in here. We're looking at the average. If you average up all the little grid boxes that go into that on a weekly basis, starting one is in January of this year. And then there's about, I think, 8 lines on there. Those are all the different El Nino events we've had since 1990. And 2 lines are clearly separated from the rest of them. The black line is this year. The blue line near it, that's 1997. So, running very much similar to it. The one difference would have been earlier on in the year. If you follow the blue line back, you'll see that it actually started out the year in the negatives. So it actually was coming off of a weaker cold event. While this year, if you remember last winter, we talked about how we kind of flirted with that El Nino. So that's, we started at a much higher base. But, over the past 2 or 3 months, they've tracked very closely. Clear separation from the other events, although there are other events in there. I think there's a pink line that's 1991 that was also what we would consider to be a strong event. So, will the black line continue along the path of the blue line? I guess before I get to that, just to put it in perspective, these are some additional events that now go back to 1950. Again, the black line is up towards the top. There's actually one that's right about with it, but you can see that one's actually on the way down. There are a couple of other very high peaks in there. One of those for folks that are really interested in climate, that was the 1982-83 El Nino, those are kind of like the 2 events that have separated themselves, at least in terms of impacts over the U.S. and around the globe from the other events. That dash line actually we just threw that on there. That was last year. So you can see the comparison of last year at this time to this year. That's why the dash line, if you look into next October there, is actually where we currently are. So let's take a little bit of time in comparing to 97. Here we're looking now at what we call a time longitude cross-section of temperature anomalies. So these are now looking at time advancing right along the equator. So if you go back to that map and the blue box was centered on the equator, that's from Indonesia over to the South American coast. So that's 130 east to 80 west. The black box that you'll see on both of these plots is that Nino 3.4 area. So that represents the blue box. And if you look and you compare the two inside the blue box, it's actually very shocking how similar the two of them are. Of course, the lines have been tracking, so maybe it shouldn't be that shocking that how similar they are. The differences actually are to the left and right, or to the east and west of the box. If you look at 97 in particular, so to the west of that box, it was actually a little cooler in 97 than it is now. And if you look to the east, so between the edge of our box and the South American coast, it was significantly warmer. And we'll see how this plays out, but we think that what that does is it means that the pattern this year is more uniform across the Pacific. So the departures are very similar when you go across the Pacific. There was a bigger, what we call a gradient. So the change from the South American coast to Indonesia was a much larger change, and that has influences on the patterns of pressure and the patterns of winds. And all these things go to help to maintain and increase the strength of the event. So, if you look at the lower, and if you look now focusing into the box in particular, so the box for 2015, if you look in the lower right corner, you don't see a thick black line like you do just starting into the box in 1997. That's the 3 degree C isotherm. So that's the where temperatures are more than 3 degrees Celsius, 5 to 6 degrees Fahrenheit for folks who don't like Celsius. And you can see that if you follow it in 97, that 3 degree C isotherm really came well out into the Pacific. That line is actually missing right now, and there's a little area further to the east, kind of a closed area. And it's these types of things that make us kind of question as to whether this event can strengthen any more than it is. It just doesn't, typically this, if you look at 97 is kind of the typical evolution where it's warmest in the east, and then that migrates into the central part of the Pacific. And if you look in the east right now, it's basically the same temperature. So that reservoir of warm water at the surface isn't there. The next slide is if you look below the surface, and a lot of times we look below the surface because things change down there before they change right on the surface. And again, this is another one of those cross sections. This starts back in August. They're both obviously very warm, a lot of reds. I think while we see, 2 to 3 degree anomalies this year, again, if you look at last year, there was a lot of 3 degrees, and we're about at the point where the subsurface became +4. And that's integrated over 300 meters of depth, so almost 1,000 feet. So a very, very deep reservoir of warm water. While it's warm this year, again, not as warm. We actually had to add a contour in 97 to do that. You can see that black. That's a +5. And again, it's not there now. It doesn't seem like it's going to be there. So it is raising questions as to just how warm this event can become. Now, our models tell us other things. We think our models have some challenges as well. But these are some reasons why, there's a lot of folks, is this going to be, and every time something happens, I tell you, the world we live in with Twitter and everything, every time something comes out, everybody starts tweeting it. And it's like, oh, it's going to be a record. Oh, it's going to be a record. It's like, no, well, maybe it's not going to be a record. We'll see. Doesn't really matter necessarily. And that's the other thing to remember, is that while this is more curiosity as to whether these things break records or not, here in the U.S., I don't think we care that much. I mean, we don't necessarily care. You know, a strong El Nino is a strong El Nino, and it should exert some influence on our winter weather this year. And, you know, whether or not these departures become as warm as 97 or whether they fall a little short, you know, hopefully it doesn't matter. So I mentioned our forecasts that don't seem to be troubled by the lack of a deeper reservoir of water. The plot on the left, that's pretty much all of the models run in various modeling centers around the world, showing different forecasts for, again, that blue box, if you think back a few slides, for Nino 3.4. This time I moved my red line, so instead of being at minus 0.5, because we're obviously nowhere near that, I moved it up to 1.5. 1.5 is kind of the notional threshold for when folks consider these events to be strong. So, you know, again, there's some averages in there. There's a yellow line that averages all of the models. You can see that they're all well above 1.5. Some are above 2. I think there's a couple that are off the plot at 3. I won't give you what I think of those particular models, but I don't think we're going to be anywhere near 3. I don't think we have any concerns there. The figure on the left, the figure on the right is some subset of these. It's a project that we call the North American Multi-Model Ensemble system. There's a couple of models, and we'll look at what these models are showing for the forecasts for temperature later on. But there's a couple from Canada. There's one from NASA has a model. There's a couple of NOAA models in here, and one from NCAR. Again, they're all you know, fairly warm, all peak out above 2 degrees C. Some folks consider 2 degrees to be more significant than 1.5. It's hard to say whether that's true or not. When you look at the events we've seen, the sample size or the number of events that have happened that way drop so low, you know, it's hard to draw a real strong conclusion. You know, if you have a favorite football team and they've won 2 games in a row, well, does that mean they're going to win a 3rd in a row? I mean, you know, it's different than if they're really good and they've won 10 in a row or 20 or 30 in a row. Then you figure they're good. 2, you know, I don't know. So, oh, there we go. That's our official, what we call our consensus forecast. Again, I mentioned it early on. Obviously, very, very likely for a climate forecast, you'll never see anything higher than these kinds of probabilities. So El Nino is here to stay, at least through the winter. And the typical evolution of these things is as we go later through the winter, in particular into the spring, they'll drop off, oftentimes fairly rapidly. Oftentimes they'll end up flipping sign, and maybe I'll be here next year talking about the next big La Nina. So we've seen that before. Actually, that happened in 97, 98. So what happens over the U.S. when we have an El Nino? Here we're looking at what we call a composite, simply just an average of cases of previous El Nino events. And I picked the 6 strongest events. The figure on the left is the average departure from normal. So across the north, warmer than average. Across the south, colder than average. And you'll note maybe the departures in particular, like in the Dakotas, you know, larger departures than the negative side down over Florida. The figure on the right is actually just that. Remember I said our forecasts are a tercile-based forecast, so the upper tercile and the lower tercile. Well, it turns out that odd number 0.43 is where you get a tercile, so that's like the 67th and the 33rd percentile. So, you know, that's where that composite, if we were to see exactly what we've seen the average of these 6 events, that's what we would expect to see with regards to temperature this winter. Now, I was cautioned by some folks at work that 6 events is not a lot of events. You could have 1 or 2 real big ones that are skewing everything. So I said, all right, well, I'll be fair and I'll show all 6 events. So that's the next slide, okay? And, you know, it turns out, I was actually surprised at this. I could not find one, and these are now climate divisions, but I could not find one climate division that had the same sign in all 6 cases. So I only had to go to 6 to get a somewhat different solution. And now these are in terms of anomalies. And I used maybe a pretty large group, although 2 degree, and I think these are actually in Fahrenheit. So it's not that large a departure on the white areas. They're actually a 4-degree window. And still, there's no grid box that's the same for all 6. So that kind of should give you some idea that certainly there is a lot of variability through these events. They're not all the same. They're ranked in order from the strongest, and that's determined by how warm the ocean was, to the weakest. So the strongest is 97, 98. The weakest here is 91, 92. One thing that I found interesting is that the 3 that are most similar, which are 97, 98, 82, 83, and 91, 92, are also the 3 latest events. They're all happened since, 1982, 83. The other 3 events happened before that, and I'm not ascribing necessarily any type of climate change to this difference, but we know that the atmosphere, and there are some patterns that have decadal variability or multi-decadal variability. And so the question is, are we looking at El Nino, strong El Nino, superimposed on top of some other mode, which is certainly a possibility. But if 65, 66, and I'm not going to show the precipitation maps here, was actually a slightly different case, even though it was the 4th strongest by peak. Actually, by winter, it was already dying off and weakening, so that one maybe isn't a great case. But certainly, there's at least some tendency for the north to be warm, or at least not as cold, and the colder, and the southern part of the nation to be at least, or in a relative sense, colder than the northern part. So what else do we have to kind of deal with? And again, I just briefly touch on other patterns. So North Atlantic oscillation, I've talked about that more in previous years. Certainly can play throw a large monkey wrench into the forecast. I will put up the time series of these average for this Arctic oscillation. You can see, though, recently, I guess it was 5 or 6 winters ago, the big negative one, that was 2009-10. Certainly for folks that live in the east, probably remember that winter with a lot of cold and snow, and that certainly can happen. 2009-10 was actually an El Nino year. So it was not one of the stronger ones. It was what we would term a moderate one. If you go through this and you look for the strong ones, what you'll generally see is that the Arctic oscillation has not been in a strong projection, either positive or negative, when we've had a strong El Nino. Does that mean that we can't? Well, I'm going to say no, right? Because we, again, the sample sizes are small. We certainly haven't seen everything. The last couple winters are interesting because the Arctic oscillation's actually been a little on the positive side, although in the northeast, central, Midwest part of the country, we've been rather cold the last couple winters. So you can be cold for other reasons besides just this pattern. We look at trends. This is tries to take and leverage things such as these decadal variability. Looking at winter, there's not much help here. It's pretty much a very flat pattern. It means if you looked at what the average of the last 15 winters, they've been very close to, if you averaged all of them, would be very close to normal. So if I put this up for some other seasons, I think the spring, there's actually most of the other seasons are warmer than this. Winter is the one season that looks like this. There's been a little bit out west, but other than that, people probably in their mind remember the last couple of winters have been cold. Well, you'll see there's no indications of that on here because, again, 2 or 3 years when you average them in with 15 doesn't necessarily make a big difference. And if you go back, I think it was either 11, 12, or 12, 13, it was a very warm winter. So these things kind of average out over time, and at least for right now, we're not seeing anything on the decadal scale. So our models, I kind of introduce these a little bit. This is again, the North American multi-model ensemble for the months of December, January, and February. Well, they have a lot of things in common. Probably not surprising since they're all forecasting a very strong El Nino, and that plays such a large role in what happens during the winter. If we were making the forecast up in Canada, well, they're pretty much all warm in Canada. Same for Alaska, so we're really confident on Alaska. Even the northern part of the U.S., but there are some differences. A couple of the models certainly have more cold in the south central, southeastern part of the nation. They all, again, have some tendency, other than, I guess, the one NCAR model. They all do have some tendency for below average temperatures across parts of the South. So if we average these, so now here's an average of those 7 models. That's the leftmost one. Again, warm north, Alaska, Canada. The figure on the right, that's actually one of our models that we run at the Weather Service, combined with 3 European models, including the European Center model. Again, the patterns are all very, very similar. When I finally get to the forecast, it probably shouldn't be a surprise as to what we're forecasting for this winter. Just to put into words, again, so we have, a strong El Nino that developed back in the spring. Certainly gonna persist, and we expect it. And I see I typed wrong, and I wrote JDF. DJF temperature trends, that's what I was trying to get to. They're rather small. So without holding up any further, there is the current winter outlook. Like I said, fairly high probability, certainly over Alaska. The northern part, actually, in parts of I guess, the northern Great Lakes and the Pacific Northwest, greater than a 60% chance of above average temperatures. It's not greater than a 90% chance, no, I'm sorry, but it is greater than 60, so it is still, these are for a seasonal outlook. These are high probabilities. We do tilt towards above average in the Northeast this year. Probably in the 11 or 12 years I've done this, I probably can count on easily one hand the number of times we haven't had equal chances in the Northeast. But at this point, the stronger events that we've seen, oftentimes we end up with a pattern like this. If you think back to the different model forecasts in Canada, and every model was warm. Well, if it's warm in Canada, okay, then it's hard to be cold in the Northeast because the cold air has to come from somewhere. And so it's not, so clearly that these models are all expecting the typical El Nino year, and it's what we're expecting at this point, which would be what we call a jet stream that, instead of arching up into Canada or into the North Pole and coming back down with it, should be very zonal, what we call. So it means it'll flow from west to east, and much of the air that we see should have originated over the Pacific Ocean, not over the North Pole. Doesn't mean certainly that we won't see some breaks in that pattern, but the predominant pattern that we would expect to see with the strong El Nino would be that very zonal type pattern. In terms of, and this is a map that we show, it doesn't necessarily mean too much. There's ways to take probabilities and convert them into a full distribution for anomalies. This is actually the shift in the median. So in theory, the median is the most likely value. It doesn't necessarily ever happen, but it is the most likely value. But 2.5, 2 to 3 degrees in the northern part. Again, the probabilities in the south are weaker, smaller. The variability in the south is also much less than in the north, so you end up with somewhere less than a degree below average. In terms of heating degree day projections, and I'm sure that EIA will do their own, and so in case our numbers, when our numbers are different, they look at a longer season. This is only for the 3-month season, DJF, or December, January, and February. I think theirs are November to March or something, but should be somewhat in the ballpark. Less than the normal, and certainly less than last winter. I do have our precipitation outlook. Found out, I guess, last year that precip actually can play a role sometimes in energy if it's wet when they're trying to harvest and they've got to dry the crops or something like that. I don't know. You guys probably know that one better than me. But interestingly, they said this is about, especially if you look over in Florida, that's a 70% chance of above average precipitation. Again, when you're talking in the realm of seasonal forecast, that's probably as high as it will ever get. But a wet Florida during an El Nino year is, again, probably the most confident forecast that we can make. Folks are interested certainly in California with the ongoing drought. again, we favor wet, especially for them. It's not exactly necessarily a great story in terms of the most likely is in the southern part of the state. A lot of their reservoirs and certainly the mountains are in the northern part of the state. Signals, what can I say? The signal's better in the southern part of the state than the northern part. The really strong events we've seen, 82, 83, 97, 98, they were very wet, even up into the mountains in the northern part of the state. So we'll have to see how that works out. Of course, then I'm also always asked to remind folks that 4 years of drought won't be wiped out in one winter. So if anyone from California, conserve. That's the message. And then just looking at kind of a series of temperature outlooks, and so this actually has the current outlook for November, December, January. Very, very consistent evolution. JFM is actually the one is the season that has is the most winter-like season, it turns out, and so the probabilities there are maybe a little stronger, especially I guess there's a 50 down in Texas, but certainly no big evolution from this map as we go through this winter and into the spring. So that's just the forecast in words, and I will stop and take any questions. Except first I'll take a glass of water. Yeah.
I asked you, a number of your slides had differences like 97, 98, and this year they were measured as anomalies.
Right.
So does that mean, but were they measured from the same base? Sorry, or does your base change because you average in years as experience goes by? In other words, would it be a higher base that your anomaly comes from this year than it was back in 97?
No, those actually are all from the 30-year 1981 to 2010 period. Now, the interesting thing is one of the things that if you looked back at some of the older El Nino events, we actually do use an older base period for those because one of the things we've discovered over the past however many years is that like there is a gradual warming trend, just, you can call it climate change, call it whatever you want. And we figured out that at some point in the future, if we kept readjusting the old events, what was an El Nino might become a La Nina because the base period keeps getting warmer and warmer. And so now what was warm back then is now cold relative to this period. So, but we're in the period 97, 98 is actually fixed on the 81 to 2010. The current one, actually, as we go forward, will migrate. We try to use a 30-year period centered around the particular years. So, but for right now, they are on the same footing. Sure.
Question and a comment. I guess the comment is thank you for coming and doing this again, Mike. It's appreciated. Mike did this originally based on a cold call and said, sure, we'll give this a try. So thank you.
And I remember that because I walked into the room and there were about 7 TV cameras,
Yes.
and I almost turned around and walked back out.
It was a year of unusual winter and unusual oil prices, and I think everybody from CBS to
Yeah.
ABC was
Well,
here.
it was a different time. Now
a different
one
time.
camera serves all,
That's true.
right?
That's true. That's true. Real quick question that isn't part of your presentation and probably outside of the scope of this, but does the prevalence of the El Nino, when we're thinking ahead particularly to spring, does it present more probability of severe storms, weather, those sorts of things, or is that really out of the realm? Do you infer anything from the temperature changes?
Actually, with regards to severe weather, and something that we probably haven't played up but is potential, is we know that during winter and El Nino, we oftentimes see severe weather in the southeast, particularly Florida. So that might be an area, and I know we've had some engagement with FEMA to alert them, although their director's been around a while and he remembers it. So there was 97, December, I think it might have been February of 98, there was one significant severe weather outbreak. When you go into the spring, actually, El Nino, you typically see less severe weather. What favors severe weather is a configuration of the jet that we don't typically see with El Nino. So the concern is more this winter in the southeast, and I said the spring we'll see. Actually, that's a product that we're toying with issuing, which is a severe weather outlook for the spring months, something similar to the hurricane outlook we do, but we're still a little ways away from rolling that out. Mike behind you.
Thank you. I'll preface this by saying that as the propane becomes more interconnected with international markets, demand in Europe will have a bigger impact on U.S. prices over the winter. And so I wanted to get your opinion or thoughts on what the impact or the weather probabilities in Europe might be this year.
You know, the folks want to have El Nino affect their weather wherever they are. And while it does have impacts in large parts of the globe, it doesn't. And at least the studies I've seen, the link between El Nino and Europe is really thin. I mean, if you think about it, it's pretty far away. I mean, it's, you know, there's been some talk, but I honestly don't know whether it favors warm and cold through various teleconnections and all. I'm not convinced that there really is as much there. Again, you know, when you're, unless something is really obvious and jumps out, when you're dealing with sample sizes of, you know, 5, 10, even 15 events, it's hard sometimes to draw real strong conclusions on that. So I know that I'm glad, while it's challenging to make these types of forecasts in the U.S., it's even more difficult for Europe. I know some of the folks over there have taken some heat for some of their forecasts in the past. And so I'm not even sure that much in the way of seasonal forecasts are issued or at least publicized over in Europe at this point. I know the UK Met Office, I think I've been told they still do them, but they bury them. So, well, they had a couple of issues back a few years ago. Anyhow, so I can't help there. I don't know, and I'm, like I said, thankful that that's not an area that's under our domain. Okay. Well, thank you.